Now we will look Euclid's division algorithm. What's maybe algorithm? Algorithm is a step-by-step procedure to perform a certain task. The steps should be miniature in its structure. That means we cannot divide the steps into further small steps. That's only the rule to form the procedure. That's algorithm. It's a word commonly used in computer engineering. Before we write these computer programs, first we have to write algorithm. Okay. Euclid's division. In this section, in number theory, Euclid's division algorithm is used to find. I have already told you that Euclid's division algorithm has many applications, theoretical and practical applications in mathematics and computer engineering. It is formed a part of cryptographic protocols in secure internet communication. But in number theory, that we have to study in the NCERT syllabus, Euclid's division algorithm is mainly used to find the HCF of two positive integers. What's meant by HCF or GCD of two numbers? HCF or highest common factor or greatest common divisor of two numbers. What does it mean? D is the HCF or GCD of A and B. Then D is the largest number that can divide A and B without leaving any remainder. That's the meaning of HCF or GCD. In order to find HCF or GCD of two numbers using Euclid's division algorithm, we use Euclid's division lemma. I have already told you that what is Euclid's division lemma. If A and B are two numbers, then we can find two unique numbers Q and R such that A is equal to B Q plus R and value of R is greater than or equal to 0 but less than B. This is Euclid's division lemma. In order to find the HCF two numbers using Euclid's division algorithm, we use this lemma. The algorithm used to find HCF or GCD of two numbers as described in Euclid's elements is not based on division process, it's based on subtraction process. We can take a brief look to that procedure to find the HCF of two numbers using the procedure as described in elements that's attributed to Euclid. To find the HCF of 252 and 105. One thing, we need not study this procedure, this section. I just told you only for your information. We have to study Euclid's division algorithm. That is method to find the HCF using division. This is subtraction. That is HCF of 252 and 105 is same as replace the larger number with the difference between larger and the smaller, that is 147 and 105. Again, replace the larger with the difference between larger and the smaller and the second number. HCF of that pair is also equal to replace the larger with the difference between larger and smaller, that is 63. This procedure will continue until the two numbers are equal. When that two numbers are equal, that number is the HCF of this our required number. The main drawback of this procedure is it requires large number of steps if the difference between these two numbers is very large. We will look the Euclidean division algorithm that we have to study in this section in the number theory. Now we will see how to find HCF of two positive integers using Euclid's division algorithm. Here we use the letters C and D to represent the numbers. Why we use C and D? That is in the previous section, that is in Euclid's division lemma, we use the letters A and B to represent the numbers. That's why we use the C and D here in order to avoid the confusion with the Euclid's division lemma. So, I have already told you that algorithm is the step-by-step procedure to perform a certain task. So, here the step 1. What's step 1? First we apply Euclid's division lemma to the numbers C and D. While we are applying Euclid's division lemma to C and D, we will get Q and R, two numbers Q and R. That is, in Euclid's division lemma we have studied that if A and B are two numbers, then we can say that A is equal to BQ plus R. We can find two numbers Q and R such that A is equal to BQ plus R, where value of R is greater than or equal to 0 but less than B in Euclid's lemma. So that we apply that lemma to C and D. While we are applying Euclid's lemma to C and D, we will get Q and R. Next step, if R is equal to 0, then D is the HCF of C and D. If R is not equal to 0, then apply division lemma to D and R. Next step, D and R. That means replace C with D and D with R. Or we can say that in our ordinary language, replace dividend with the divisor and the divisor with the remainder. And the process continues until R is equal to 0. That the remainder is 0. When the remainder is 0, then D is the required HCF of C and D. We can understand more clearly with the help of an example. Next we will do an example. So here we have to find the HCF of 252 and 105 using Euclid's division algorithm. I think we have done this example in original Euclid's algorithm, that is on subtraction method. So I have already told you that you need not study that subtraction method. Okay. So here C is equal to 252, D is equal to 105. What we have to do in step 1? We have to apply Euclid's division lemma to C and D in order to find Q and R. In order to find Q and R, we will use long division method. It's a shortcut method. That is 252, 105. Dividend, divisor. We will get quotient as 2, remainder as 42. How can we write it? We write this step in this way. 252 is equal to 105 into 2. The test of divisibility we have studied in the earlier classes. Here R is not equal to 0. What we will do? Apply division lemma to division lemma to D and R. That means replace C with D, D with R. That is, replace C with D and D with R. That's we have written here. Then, in this step also R is not equal to 0. Then what we will do? Again replace this C with D and D with R. Or replace dividend with the divisor and divisor with the remainder. That's we have written. In this step R is equal to 0. While we find the value of Q and R is 0. When R is equal to 0, then D is the required HCF of C and D. So this is the step I have written, and this is the algorithm. That is, number of steps are required to find the HCF of two numbers using Euclid's division algorithm is less than 5 times the number of digits of the smaller number. Original Euclid's algorithm, the step is enormous if the difference between the two numbers is very large. One more example, find the HCF of 320 and 132. Here C is 320, D is 132. First we will apply Euclid's division lemma to C and D in order to find Q and R. Value of R is greater than or equal to 0 but less than D. C. Dividend, divisor. This is the method to find the value of Q and R. 2 times 260, 56. So dividend is equal to test of divisibility 132 into 2 into 1. Here this is Q, this is R. R is not equal to 0. What we will do? Apply division lemma to D and R. In other words, we replace here C with D and D with R. Or we can say that replace dividend with the divisor, divisor with the remainder. In the next step, R is not equal to 0. What we will do? We will continue the process until R is equal to 0. When R is equal to 0, then this one, D is the HCF of 320 and 132, that is 4. So, this is the steps I have written here. This is written here. This is written here. This is the step, and last is this one. You need not write these arrows. I just put these arrows to understand what is the steps here used here. So you need not write arrows. This is the algorithm, not this one. This is the algorithm. This step is used to find the value of Q and R, but this is the algorithm. Next, we will prove some properties of numbers based on Euclid's division lemma.